The button scrolls by turning like a radio dial would, and then if you push it, it's the enter button. The bottom button is the back button, and this is to the main menu. If you were a couple menus deep and you hit this, you'd come back to this menu. Your alarm bell obviously brings you to your alarm log. Active alarms show up at the top. Your logged alarms show up below, and you can go in, into those and read them going downward. And then if you had an active alarm, it would show up in here. The alarm logging itself doesn't necessarily log a lot of data with it. It tells you what and when, but it doesn't necessarily give you information at the time of the trip. But it gives you a starting point. Basically, if you start off with the password, it'll give you all the menus available, 63. Every time I do it, I just press it for enter to enter the number, and then 63 again. And then I have full menu options. So view set, I can go into the temperatures menu for the water side, see my leaving water, entering water, a couple other points, delta T, the set point it's currently running on, pull down rates, outside temperatures. Anything that highlights all the way across is a set point you can adjust, basically. We're not doing ice, so that point's basically out, but your chilled water, your cooling, leaving water set point essentially is here. Now, depending on how it's set up, I'll take a peek at the setting on this. It could be that it's already set up to be done on the back net, which it looks like it is. With that being said, if you adjust this set point and the back net's writing to it, that set point's not gonna do anything unless you take the control away from the back net. So keep that in mind, that set point in this application right now is not gonna help you any. But there's a lot of good data points just in some of those menus. So let me see if I can, looks like network, local.
Points in the manual.
Oh, local, nice. Sorry, say that again.
All the backnet points in the manual for it, like.
There's a separate backnet points manual, basically.
Yeah.
I assume the control guy has it, but okay. He's not here to ask. If for some reason that he doesn't, just reach out to us or the rep, and we can get it to you if you want to have it.
Yeah.
I don't know again what points he's going to provide. There's a lot of points available. I assume probably too many that you don't need. He's probably going to limit it based on his scope. But in the future, if you want to open up or add more points, we don't really limit any points. So he has the ability to, in the future, give you more access if he hasn't already. If that's outside the scope, you can talk to him about that further. But I would say whatever he's giving you now is within that spec. And that's what, talk to him about what he has already and what you want moving forward. But for the most part, again, it's a chiller. It makes chill water. You get the set point, you get the on-off. From there, if you're having issues, you're going to want to come to the chiller anyway, so you're not going to really need multiple variable points moving, over the back net.
So what refrigerant?
This is 134A.
So the top one's chiller 1, that's chiller 2 down there?
No, basically the top one is the main controller, and this one's just for the fans.
Okay.
So this one tells this one, run the fans based on this, and then this one does all the communicating to those fans. There's so much to control with the fans, with so many fans, they need a whole nother basically a whole nother controller to be able to do it.
Okay.
So the nice thing is that in this menu here, you set circuit, you can go by circuit. We only really have one compressor on each circuit, so let's call it 1 and 2. Compressor 1 and 2 is circuit 1 and 2. And right now we have number 2 running, so we'll be able to get some good stuff out of that one. So you get data, will show you all your numbers. Your status menu, tell you what your capacity is running at, stuff like that. Your compressor menu will give you your run hours and starts, your capacity, your speed and hertz. You can watch it on the drive, your motor current. You can watch, it's like I said, anything you can get from here, for the most part, you're gonna get here. Stuff that you need to see to operate. We do a lot of calculated values, kilowatt uses and stuff like that. On your condenser side, you can see how many fans on that circuit are running, what we're targeting for temperature to control those fans. Again, this is telling those fans what to do based on the operating data from this controller. And expansion valve. You can see how it's controlling the superheat, what its targets are, and then in your data menu.
Superheat.
The target changes based on operation, so it's fully variable target because they're electronic. We can do that. Years ago, it would be 6 to 8 or 8 to 10, depending on the chiller application. We didn't vary much. In this case, it'll start off in a pressure mode and just try to maintain pressure until it gets going. Goes into a superheat control. It might start off at like 15 degrees and then work its way down. So you may see it anywhere from 5 to 15 or something like that. Just depends on it. So they give you what the target is as well as what you're actually doing, so you can see the difference. And if you look at the capacity of that valve, if you're at doing 20 and the target's 15 and you're at 100%, you're probably a little light on gas.
Right.
You know, you can kind of guesstimate those informations just by looking at where the valve actually is. If you're at 50% and you're at 15, the target might be 15, you might be right on point. So the nice thing about that is you can kind of get a better idea where your charge is because you know what the valve's being told to do. Doesn't mean the valve's doing it. If there's a breakdown between there and there, you may have a good charge, it might be a valve problem, but it gets you a little more information because you can see it on the screen. You're not assuming, oh, maybe that bulb's not working, you know, that kind of thing. And the nice thing is I can show you there is the ability to put it in a manual mode and you can fully control all the different points. So you wanted to shut the chiller down completely and run through outputs. See the fans work, see the valve drives, see that all your solenoid coils bang on when you tell them to, that kind of thing. You can't in manual mode like run the drive or anything, but every other component, safe component that you can run gives you that ability on like a shutdown to spot check. So the next season you got a broken component, you change it out before you start up, that kind of thing, which is really nice. But yeah, if you go to the data menu, you get to see all that. EVAP pressure, condenser pressure. It gives you the PT chart there for you so you can know what your saturations are. Gives you suction temp, your discharge temp, your suction superheat, and your discharge superheat. And those are the two critical points on these machines basically is we care about maintaining a good discharge superheat, not too high, not too low, and obviously suction superheat, control that valve. Those are the two most critical points of operating the refrigerant circle on these. And they'll give you other stuff like your evap approach that you're doing, what your condenser approach is doing, that kind of thing. The other thing these do is they look at pressure ratio across the screw. Because we unload that screw with the drive, we are concerned about obviously the lift or the pressure ratio across it. So we have valves in there that can maintain pressure ratio even at low speeds, just by basically blocking off the discharge ports to stack that pressure up, which gives us the ability to, we used to not be able to unload a screw past like 24 hertz. Now we can go like 14, 12 because of that pressure ratio control. And then the other thing is oil pressure. So we read oil pressure as difference between condensing or discharge pressure and an oil pressure sensor. It's across our oil filter. So if you get oil pressure alarms, usually the trip point's somewhere like 36 pounds or so. If this starts, you know, going past 25 or so at full load, you might want to start thinking that your oil filter might need to be changed. We don't say do it based on hours or operation or any of that kind of stuff. We do suggest doing an oil sample once a year at least, but we don't suggest changing that filter until that's a problem. So we monitor that on a basis. But everything that controls, again, the valve system within that compressor used to be a slide system that controlled the staging. What we're doing with the drive now. So we do have a couple valves there to do that pressure ratio control of those discharge ports. Those are run on pneumatic oil pressure within that compressor. So if you are, not maintaining these oil filters, you could potentially have problems operating that screw properly. So it's a good thing to keep an eye on, that on a regular maintenance when you're logging your machines. Other than that, most of the stuff is configuration stuff and stuff that's you're not going to change that we've already configured for the unit. So you really don't need to go into that too deep. But feel free to poke around, try out the controller for yourself, maybe navigate a little bit, see if you got any further questions you want to discuss about the operation of it. And if you want, we can do a walk around. If there's anything you want to point out, talk about more in depth, we can do that as well.
So shutting down the unit, those are the switches?
Yep, pump down per compressor, and then the unit switch itself. So if you shut the unit switch down, the whole thing just stops. Okay, I suggest doing one circuit pump down at a time.
Compressors DC, AC?
They're AC. So it's off a standard VFD like you would have on a blower. So I guess in theory the drive goes AC to DC back to AC again is what I'm told. But the motors are technically AC motors. But they're rated to do the higher frequencies. We can, depending on the application, again, without looking at your submittal, I don't exactly know your total ranges, but it could be as high as 86 hertz on the high end. And as low, like I said, is 12, 14. Just depends on the application. There's a couple different compressor sizes, and they just respec them based on the barrel size, how many fans, and then they readjust how they're going to run them basically from the drive. The drive does pretty much all the work. which is nice. It's quieter, as you can tell. Most screws are screaming by now. So, and obviously, the lower we unload, the quieter it gets. So we get up to 86 hertz. It starts to get a little, high pitched, but not nearly as loud, because our screws are a single rotor screw, whereas most people have 2 screws. We use 2 gates and 1 big screw in the middle. So they're less mechanical connection there. So it's not as noisy.
Like minimal load on them. Like, say, most trailers need like a decent load on them.
Yep. For the most part, and I have to check the mills to see exactly where the spec line hits, but usually it's around 10%, believe it or not. It may be slightly above that, 12, 15, but usually it's no more than 20 of actual full load capacity. They have that ability to unload. So without looking at the submittal, I'm going to say somewhere probably between 15 and 20, but it could be in theory as low as 10, depending on the application. Because as long as the operation of the system, the minimum flow conditions, bypass valves and all that stuff are controlling properly and installed and set up properly, this thing can turn down really low, sit there at minimum flow, run at minimum speed, doing within a degree of set point. Assuming, again, all perfect conditions, obviously, which we all know doesn't always happen, but they do a really good job of sitting there at low load and just kind of coasting. And again, all that has to do with is because we can control pressure ratio on that slide set and control the motor speed. If we couldn't do both of those things, we'd get to minimum load and we'd struggle in the middle of the winter because we're not totally controlling head pressure, we're staging fans. In this case, we're totally modulating head pressure. That whole coil has an even temperature and an even pressure across it. It's not like one's on a drive and the rest of it's heating up, banging fans on it. A lot of fluctuation there. This is going to be very even all the way up. So.
You guys not do anything with free cooling at all?
Nothing here. We don't currently do anything in general within the chiller. I know there's a couple chiller manufacturers out there that have it built within the chiller.
Like Lever, we saw.
Yeah, there's another company that did it first, and I forget the name of it, and they use Blitzer screws, and they have a double coil in their condenser, and they use the fans to do the. We've never gone down that road, and I don't know how well it does work for other people. It's a good idea. We've never gone down that road, so I don't know if it'll ever happen, to be honest with you. Most buildings, they incorporate it somehow with a plate-to-plate or some other like dry cooler next to the chillers or something like that. And usually works better. It's just more equipment to buy. But I would say the cost of the chiller with all those extra controls and that extra equipment probably negates that cost. So they probably look at it as not really a win-win to go down that road. But
You can get those guys to walk through.
yeah, oh, absolutely.
Yeah. Okay. Thank you.
Yeah, no problem.